Hello, my name is Darren Thomas. I am the Director of Educational Research Techniques. This is Simpler, using machine learning algorithms in R. We're in our final lesson for Unit 6, Chapter 6, if you will, and we're going to do our model testing for our linear discriminant analysis, where we're trying to predict what class a particular student is in based on their reading score, their math score, and the experience of the teacher. So why don't we go ahead and move over to R. And so you need to run your packages again. We need the mass package in particular. We don't really need that, but it's not a bad habit. Set our seed again. And so now this is what we're going to do. We're going to create a model called predict.lda. And what we're going to do here is we're going to use the predict function, and we're going to use the model that we created in the last video, and we're going to use some new data called test.star. This is our test data. So that's that's line 5. Let me clear this, sorry. Line 5, there we go. And now we're going to take a look at the results. And so what we're going to do here is we're going to compare the results of our new predict model that we just created, the classification that it makes, versus the actual classification of the test set. So I press Control Enter. And so if you want to look at that, you just type in results here. Result. And you can see right there. So everything along the diagonal going from the top left to the bottom right is correctly classified. So you can see here regular right here, small class, and then regular with A down at the bottom. Now, to get an idea of how accurate this is, we're going to use this code in line 7. Now it's a little complicated, so I need to explain this a little bit. What we're doing here is we're taking the sum of the diagonal of the result table. That's what we're calling this table right here, result. And we're dividing by the sum of everything in the result table. So what's happening here is R is going to add up the diagonals and divide it by all the numbers in there. And that's how we'll get an idea of our accuracy. So we do this in line 7. Line 7, and you can see our accuracy is about 36%. That is nothing to brag about. There's a lot of misclassification happening in this model. But rest assured, we're just doing this for demonstration purposes. We're not trying to do this for any kind of professional reasons. Now, we can also, because we only have, the two functions, we don't have a lot of information, a lot of complexity to the model. We can actually map this in a plot. But here's the thing. We have about over 1,700 different predictions. If we put everything on the plot, you're just going to see a giant black mess of blob, and you're not going to be able to appreciate it. So instead, we're just going to take the first 50 samples to get an idea of kind of what's going on. Because like I told you, if we put everything on the plot, it's just going to be one giant black glob, and you're not going to be able to see anything. So first, we're going to plot the predictions, and you want to predict the X. That's what the X is. So let me just show you what the predict.lda, what the X looks like. Let's see here. I just want the head. So we'll do that real quick. And so it gives you these two values. The X value inside the predict.lda, it gives you the plotting of each point when you use the function LD1 and the LD2 function to plot it. Because we have only two functions, we can plot this. That's why two functions makes two dimensions, if you will. And so you can see this first guy, he'll be at negative 0.03 and 1.28. That's kind of, LD1 is kind of like the x-axis, LD2 is kind of like the y-axis, if you will. So that's what's happening inside the x, value inside the predict.lda object. And so we're going to plot this right here in line 10. And so we get this nice plot over here. And then the dots don't mean anything to us. So we have to use a text function where it gives us the actual names of each dot. So whether the prediction was, regular class or small class or class with the aid, whatever. So we do that, and as you can see, things look a little bit better. Let me make this bigger for you. And now, what we need to do now here is this. Where the 0 is at is where the line is drawn, right here, going across. And so we're going to use the ab line to set up our zeros, and that will give us a picture of where our functions are at. Okay? All right. So I know that might be hard to see, but this is our function. So let me zoom in a little bit for you, and we could talk about this. So you can see right here that we have a clear blue line right here at 0. And you can see that it does a good job separating the green regular with aid from the red small class. So the first line here does a good job separating. But what we're having a problem here with the second line is way off to the left. It's not really separating anything from anything. You can see right there that is not separating anything at all. This is why our predictions are so bad. It's because the second line is not doing a good job. It needs some help. We need additional variables to help separate the two or something like that along those lines. But because of that, this is why we're having all those problems. Also, you can see that there's a clear distinction between a small class and a regular class with an aid. However, you can already see that there's not much of a difference between a regular class, that's in the black, with a regular class with an aid, and there's not much of a difference between a regular class and a small class. So this is another reason why our model is not doing very well. It's not discriminating between the black color when compared to the red and when compared to the green. That is our primary problem here. And of course, to address this, we would have to find additional variables to put inside the model or something else along those lines, or maybe a different type of algorithm. This is the problem that we're having here. Let me zoom out again. And so this kind of explains what's going on here in terms of why there's a problem. So I hope this was useful for you. This is very interesting, how to use linear discriminant analysis where you're working on classification, which is a very core technique, of course, in machine learning. So in this video, all that we did was we simply ran our test data, and we did some prediction. And once we did the predictions here in line 5, we found out our results for our table, and we found out that our results were dismal, at 36%. And then we used the visual to try to figure out, okay, well, what's going on? How can we, improve this? What's happening? And you can see just from the picture, running the plot and adding using the abline.doc functions in line 13 and 14 with the set to 0 there, that the primary problem is that we're having a hard time discriminating between regular and small class and regular with aid classes. That's where the problem was at. So I hope that this video was useful for you and that you're able to do linear discriminant analysis on your own in the future. So my name is Darren Thomas. I am the Director of Educational Research Techniques. This is simpler using machine learning algorithms in R. Thank you.